Go with one more kind of problem called Dining Philosopher problem. So what this Dining Philosopher saying is, in general, if you have a dining table and they are gathered for a meeting, and something like I say philosopher 1, philosopher is nothing but a normal person only who is thinking, and something like that, P3, P4 and P5, right? So initially they are sat on the table and they are discussing something and they are thinking also. While thinking, they might be hungry, something like there will be some food is there, they might be hungry and they need to take that food. But the condition here is, if they want to take the food, they have to use the forks which are placed one adjacent to them, right? One will be left side, another one will be right side. I can say this will be a kind of fork and this will be a philosopher. This is the problem, right? And one more condition is, when if they want to eat, they have to compulsory take two forks and they have to eat. With the help of single fork, they couldn't able to eat. That is one more condition, right? Which means that what? When they are hungry, when they will eat only when, if they have two forks, those two forks should be compulsory left side fork and the right side fork. That's it, right? So this is what we called as a dining philosopher problem. For this problem, how many persons can be allowed at a time to take the food? 5. If 5 will be allowed, is it possible? No. Only 2 will be allowed, right? If I give a chance to P5, he can take this 4 and he can take this 4. And can I allow P1? Even if I allow it, it couldn't possible because this was allowed by P5. So can I give chance to P2? Right? And there is no other chance. Means at a point of time you may give only two particular philosophers. So for that I have written the code. So let me take, there will be a philosopher, and who is the philosopher is presently working, int n, or I can say that the philosopher number, int n. So this process is going to be continuously happens while of true. So initially they are in thinking mode. So once they may get hungry, so if they get hungry, can they able to directly eat? No, they have to take the forks first, right? So they can take the left side fork, something like I, right? Which I say, assume that this is related to philosopher I. Philosopher I has to take the philosopher I as a left fork, and they has to take right fork. How they will take the right fork? By taking I plus 1 mod n. N means what? Number of philosophers. Which means taking left fork, here it will be taking right fork. Once they got the chance of taking the left fork as well as right fork, they can allow to go for eating. Right? Once they complete its eating process, what they will do again? They will put fork of I and put right fork of I plus 1 mod n. Right? So this is nothing but put left fork and put right fork. Hope you are understanding, right? Why I have taken here I plus 1 modulus n? Suppose for example, this is the fork number 1, or let me say 0, 1, 2, 3 and 4. Next, for this person, what is the fork number here? 0. 4 plus 0 plus 4 modulus 4 is what? 0. That's why I have taken here I plus 1 modulus n. Right? So this process is going to be iterated continuously until it satisfies it. Right? So if you are going to clearly analyze this one, again here you have the problem. If you take this as line number 1, line number 2, line number 3 and line number 4. Right? Suppose if they executed sequentially, P1 completed first, then P2, then P3, then P4, then P5, there won't be any problem because of they are cooperative each other. Suppose for example they are competitive. If they are competitive, how it will be? Process P1 executing first instruction, and they preempted. And process P2 got the chance, executed first instruction and preempted. Process P3 executed first instruction and preempted. Plus process P4 executed first instruction and preempted. Process P5 got executed and first instruction and preempted. Means initially all got the chance and they used to take only 1/4. Now obviously one particular philosopher will get the chance to execute. Assume that P1 again get the chance. If it execute the line number 2, what will happen? Is it allowable? Is there any right side fork is there? No. It is going to be inside. After certain time, again this will be exited and given chance to someone. Line number 2, line number 3, line number 4, P4 line number 2 and P5 line number 2, like that. Right? Now after P5 again it will give chance to one of the philosopher. Even if it is going to give a chance, assume that P1 got the chance again, line number 2. It is going to be in this particular state only, right? Means what will happen here? Our problem not yet solved or not yet stopped. Neither stopped, not solved, right? So this particular problem we call it as deadlock. So what happened here? P1 has one resource and waiting for the P2 process to release the resource, and P2 have already one resource and waiting for another resource which is from the P3. P3 having one resource which is waiting for P4. P4 having the one resource which is at the P5. P5 is having one resource and which is waiting for to release the resource by P1. And this is a kind of loop or not. This loop we can call it as deadlock. Again here the problem is because of synchronization, right? So there will be a problem. That problem we can call it as deadlock problem. This is arise because of the synchronization. Again because of common shared data. We got this problem.